Our second test using our flowchart up here is, let's get rid of some of that ink. So in 3a, we're trying to determine if the limit as k approaches infinity of u sub k is equal to 0. And so one of the first ways we did that was we looked at infinite geometric series, and geometric series were very easy to use because all we had to do was write it in the geometric form and then look at the r value and determine if that r value is between -1 and +1. And so our next step before we get into all these different tests we do is we want to determine, is the limit as k approaches infinity of u sub k equal to 0? Yes or no. And so the second test we're going to be doing is something called the divergence test. And so the idea behind the divergence test is if you can show that a series has a limit of u sub k that does not equal 0, which is basically saying the values in here are not getting smaller or approaching 0, then you know right there that the series is not convergent and your testing is done. And so what we're going to do here is we're going to show that this particular series diverges. And again, they're using the word show, so we know this series diverges. You just have to prove it does. And so the way we do that is you look at the limit as k approaches infinity of our rule, which in this case is k squared plus 3k plus 1 over 4k squared plus 3. Now, there are a couple different ways we can tackle this. If you remember some of your rules with asymptotes from junior year, we can look at this particular function or this rational expression and notice that the powers are equal. So we looked at, remember, top heavy versus bottom heavy, and in this case, it's equal. So if they are equal, you're allowed to look at the leading coefficients, which again, they happen to be the first terms here, but remember, that's not always the case. And so I look at this and I see k squared over 4k squared. And if I look at those leading coefficients, I notice that they're equal to 1/4. So right there, this tells me the limit as k approaches infinity of this particular expression is equal to 1/4, which does not equal 0. Therefore, that immediately tells me, using the divergence test, that this particular series diverges. Now, let's say you don't remember that, or your asymptote rules are a little fuzzy. Another way you can approach this is to simplify this expression. And so the way we do that, let's rewrite k squared plus 3k plus 1 over 4k squared plus 3 is to find the largest value. Let's go ahead and write our limit. Find the largest exponent of k and multiply the top and the bottom by the reciprocal of that, so 1 over k squared. And we discussed this earlier this year, that this is kind of a longer way to do it, but it's essentially a way to prove that this value is equal to 1/4. And so if I do that, I end up getting the limit as k approaches infinity of, and so k squared over, or times 1 over k squared is equal to 1, plus 3 over k, plus 1 over k squared over, and on the bottom, we have 4 plus 3 over k squared. And now we're going to use the idea that when you're evaluating limits to infinity, so in a different color, if you have a value that is a constant over something that gets infinitely larger, which is what we have here and here and here, that we say that that limit is equal to 0. Because again, this is staying the same. As the bottom gets infinitely larger, then the fraction itself will have to approach 0. So this part, and this part all approach 0, which leaves you with 1/4. So the limit as k approaches infinity is equal to 1/4. And again, we prove that as long as that value does not equal 0, then that tells me these don't approach 0, which means your series diverges.